Hello class. Today we're going to cover section 3.6 using double angles and half angle formulas. Here are the formulas you're going to need to know. And so you can see that sine, the double angle sine, is one formula. And then with cosine's double angle, there are three. So we're going to be using these to solve problems. And so let's go through this and let's do our first example. You should write these down for your quiz. It's going to be useful. So in this first one, we're talking about sine. And so since sine is what we're talking about, and we're in the second quadrant, and the reason we're in the second quadrant is because of this restriction here. We're going to be right here, that's 5. This lift is 3, and then here's x. So then we're going to go x squared plus 3 squared is equal to 5 squared. So x squared is plus 9 is equal to 25. X squared is equal to 16, and then x is equal to plus or minus the square root of 16. But since we're in the second quadrant, we know it's the negative value. Now that we have that, we're going to use our double angle, and we know that sine of 2 theta is equal to 2 sine theta cosine theta. We know what sine is because it was given to us. That's 3 over 5. And cosine is going to be a negative 4 over 5 because cosine is x over the radius. And so this is going to yield us a negative 24 over 25. So there's our first solution. Sine of 2 theta with these restrictions is a negative 24 over 25. Now cosine of 2 theta, since we want to use something that has sine in it and makes it easier, 1 minus 2 sine squared theta is a very useful one, because we already know what sine is. So we're going to go 1 minus 2 times 3 over 5 squared, which is going to give us 1 minus 2 times 9 over 25. And then that's going to be 1 minus 18 over 25, or our solution will be 7 over 25. And that makes sense since we're in the second quadrant. We're going to yield this solution. Okay. There's some formulas also that we need to have, and we're going to have tangent here, the double angle for tangent. This is going to be useful. And then the ones that follow, these ones here, later on in mathematics, and maybe in this class, but later on in mathematics for sure, you're going to want to know these because you're going to be doing a thing called power reduction. So sine squared, you want to make it something that's not, so you convert it to something in terms of cosine. Cosine squared, you also do the same, and then tangent as well. Those are the power reduction formulas. You should know those. Okay, let's do an example. And here we go with this example. This is going to be cosine to the 4th, so we should rewrite that as cosine squared theta squared, because since we want to use the reduction, we want to use something in terms of cosine squared. And so in terms of cosine squared, we broke down that cosine to the 4th like that, and so we're going to get 1 plus cosine 2 theta over 2, and then we're going to square that. And when we square that, we know that this top piece is going to, oh, that bugs me. We know that this top piece can expand to be 1 plus 2 cosine 2 theta plus cosine squared of 2 theta, and then that's going to all be over 4. Well, we can do a further power reduction, so we're going to get 1/4 plus 1/2 cosine of 2 theta plus 1/4, and then we're going to do a reduction to this, so that will be 1 plus cosine, and then it's double the theta, and it's already 2 theta, so it's going to become 4 theta. And when we expand this, we're going to get 1/4 plus 1/2 cosine 2 theta plus, and then we're going to get 1/8 plus 1/8 cosine 4 theta. Now cleaning this up, I'm going to get 3/8 plus 1/2 cosine 2 theta plus 1/8 cosine 4 theta. And that is an equivalent to cosine to the 4th theta. All right, in our next example, we are 1 unit circle revolution, and so we can rewrite this as sine of theta cosine theta equal to -1 by multiplying by 2 to both sides. Now we know that cosine, or 2 sine theta cosine theta, is the same as sine of 2 theta equal to -1. And then when we look at the unit circle, we know that sine of a theta is equal to -1 at 3 pi over 2. Well, if the angle is 3 pi over 2, 2 theta has to equal 3 pi over 2. And so that tells us that, but we're going to do revolutions, and so since we're doing revolutions, we have to take into consideration the 2 pi k. That's the number of revolutions. Even though we're only going to do 1 revolution, we need to use that restriction because it will help us find solutions. So dividing everything by 2, I'm going to get 3 pi over 4 plus pi k. And now we need to see how many of those fall in the first unit circle. So when k is 0, we're going to get 3 pi over 4. When k is 1, so let's see what that is. 3 pi over 4 plus pi times 1. That's going to be 3 pi over 4 plus 4 pi over 4, which will give us 7 pi over 4. And that is under 2 pi, so that's also a solution. And then let's see if going 2 pi revolutions would do it. So then 3 pi over 4 plus 8 pi over 4 gives us 11 pi over 4. This is too big, and so our solution are only these two, 3 pi over 4 and pi over 4. The crux to this problem, though, is when you're solving, look for this. You got to remember that sine has a period of 2 pi, and so the answer will repeat every 2 pi. And so we need to use that when checking the restrictions. That will be important. Okay, some more formulas for you to know. These squared functions, we want to do power reduction to them. Here are some other formulas that you can use that you should have memorized that will be useful. The squared ones, I mean, you can use these. These are fine, but really what's happening is we're going to be trying to get everything down a power, and so we're going to use the square rooted ones. And so let me show you an example here with cosine of 15. Now cosine of 15 I can rewrite as cosine of 30 over 2, right? And notice in these problems, in the formula, it's just the numerator that gets plugged in. So this thing's going to be plus or minus the square root, and then let's see, it's going to be 1 plus cosine of 30 degrees over 2. Well, 15 degrees puts us in the first quadrant, and cosine's positive in the first quadrant. So we're going to be positive 1 plus, And then cosine is radical 3 over 2 over 2. So that's going to become 1 half plus radical 3 over 4. You could leave it like that, or you could even do this. Go 2 plus radical 3 under the radical, and then pull out a half. And what I did there is I just made the common denominator of 4, and then took the square root of 4 and pulled it out. Now, so this one we knew was in quadrant 1. Sine of negative 15 degrees we know is in quadrant 4. And so when we use the formula for sine, we're going to use the negative one because sine will be negative in the fourth quadrant. So this will be 30 over 2 with a negative out front, and the reason that is because sine is an odd function, and so if I have sine of negative theta, that's equal to negative sine theta. That's one of the things I covered earlier on. And so negative square root of 1 minus, and again it's radical 3 over 2 over 2, which is going to give us a negative 1 half minus radical 3 over 4. And again, we could do the same thing that we did there and go negative 1 half square root of 2 minus radical 3. And that's its solution. Okay. In our next problem, we're looking at cosine, and we see it's a negative 3 and then radius of 5. So we're going to get something that's going to be a negative 3 and 5. We need to find y. So we're going to get negative 3 squared plus y squared is equal to 20. Jumping the gun. 5 squared, so 9 plus y squared is 25. Y squared is equal to 16, so y is equal to plus or minus square root of 16. But we know we're in the second quadrant, and so y is positive. So now, when we look at this problem, we're going to go sine of alpha over 2 will equal 1 plus cosine of alpha over 2. And actually, I think it's minus here. I think it's minus. Let's confirm that. Yeah, it's minus. And then it's positive because we said we're in quadrant 2 and sine is positive. So we're going to go 1 minus. And remember, cosine is x over the radius. So that's going to be a negative 3 over 5 over 2, which is going to give us 1 plus 3 over 5 over 2. And that's going to clean up to be 8 over 5 over 2. And that cleans up to be 8 over 10 square rooted. And we can clean that up. That's going to end up being 2 radical 5 over 5. Okay. Our next problem is the tangent. And remember, tangent is all students take calculus, so we know we're going to be negative. So then, since we're negative, we're going to get, let me do this in a different color so you guys can see. I'll do it in blue. So tan of alpha over 2 is going to be equal to the square root, and it's the positive one, it's the negative one because we're in quadrant 2, of 1 minus cosine alpha over 1 plus cosine alpha. So we see that that's going to be a negative 1 minus a negative 3 over 5 over 1 plus a negative 3 over 5. And then it's just fractional work, right? So we're going to get 8 over 5 over 2 over 5. Well, the 5s will cancel, and so we're going to get 8 over 2, which will be negative negative times the square root of 4, which yields a negative 2 as our solution. The key to these problems is really understanding where we fall. This is super important, and then being able to do these kind of triangle things here. That will be very, very helpful. Please practice that. It will be important. And then one last thing I wanted to talk about is tangent's half angle. Here's the half angle that will be useful for this. So please have this written down. There'll be times you'll want to use cosine, 1 minus cosine over sine, and there's other times you'll want to use sine over 1 plus cosine. Really it won't matter, but they're just formulas that you can use to simplify depending on what the problem is asking. I hope this has been beneficial. As always, all the best.